is an expression of randomness or disorder. The more disorder in a system, the higher its entropy. All spontaneous processes, those that occur without the input of energy, are accompanied by a net increase in the entropy of the universe. This is known as the second law of thermodynamics. Entropy, S, increases in molecules as they become more energetic, which is thermal disorder, or have more freedom to move around in space, which is positional disorder. The entropy of a substance increases as it moves from a solid to a liquid to a gas. The jumps in entropy values at the phase transitions are due to increases in positional disorder. Individual substances have standard entropy values, which depend on how flexible the molecule is, and whether it is a solid, liquid, or gas. For a chemical reaction, the change in entropy under standard conditions, delta S naught, can be calculated by subtracting the standard entropies of the reactants from the standard entropies of the products. Standard entropy of reaction can be found by summing the standard entropies of the products, subtracting the sum of the standard entropies of the reactants, while being mindful of the stoichiometric coefficients. Remember that entropy is an extensive property. Amount matters. At absolute zero, a pure substance exists as a perfect crystal, and its entropy is zero. This is the third law of thermodynamics, and it allows absolute entropy values to be calculated for pure substances. Here is an example. Calculate delta S naught for this reaction. O2 gas plus 2H2 gas react to form 2H2O gas. Delta S naught is equal to the sum of the standard entropies of the products minus the sum of standard entropies of the reactants. First, we add up the standard molar entropies for the reactants, oxygen and hydrogen gas, resulting in 466.2 joules per Kelvin. Next, we do the same for the product, in this example H2O, which results in a value of 377.4 joules per Kelvin. Subtracting the value of the reactants from the product, we arrive at the change in entropy for the reaction, minus 88.8 joules per Kelvin. Entropy, S, is a measure of randomness, or disorder. The second law of thermodynamics states that the entropy of the universe increases with each spontaneous process. All molecules have specific entropies that can be used to calculate the entropy change of a reaction according to the formula. The change in entropy under standard conditions equals the sum of the standard molar entropies of N moles of products minus the sum of the standard molar entropies of M moles of reactants.